Okay, welcome to Mr. Bresciani's math class. Today we're looking at 7.3, finding the volume of a cylinder. So our content objective for today is I can determine the volume of a cylinder. And our language objective for today is I can explain to someone else the steps necessary to find the volume of a cylinder. Now let's take a look at our first example. Okay, so as you can see here, I've got my cylinder right here. In this question, my radius is 4 centimeters, a little bit harder to read, and my height is 11 centimeters. Just a quick refresher here, remember, the height is always equal to the distance between the two bases. And in this case, our bases are obviously a circle because the bases of a prism always show the shape of the prism. So a cylinder, the main shape is a circle. The distance between the two circular bases would be our height. Now, looking at how to find volume of a cylinder, very similar to the volume of any of the prisms, because it always starts with the area of the base multiplied by the height. So in this case, it's the area of the circular base, which is right here, and the height of our cylinder, which is right here. So really, we can start with our formula, volume equals. Now the area of a circular base, well, just as a refresher here, the area of a circle is always pi r squared. That's important to remember because we're going to do that when we're looking for the area of the base because we're just finding the area of that circle. So volume equals pi r squared multiplied by our height. Well, let's fill in what we know. So volume equals, well, pi we know is 3.14 multiplied by our radius squared. Well, as you can see, our radius is 4, so multiplied by 4 centimeters squared. And our height is 11 centimeters. So when we look at our volume again, it should be 3.14 for pi. Our radius squared, which is like saying radius times radius. So 4 times 4 we know is going to be 16 centimeters squared. And multiplied by 11 centimeters, which is our height. Now we have to work on our base here quickly. So we're going to do 3.14 multiplied by 16, which gives us a grand total of 50.24 centimeters squared. And we're just up with our height, which is 11. So when we multiply those together, we get a nice grand total of 552.64 centimeters cubed, as always, because we know volume is in cubes. Example 2. So we've got our new prism over here, which has a height, as you can see, because of the distance between two bases of 10.5 and a radius of 2. So using what we know from our formula, we're going to try this one now. So we know that volume is always equal to the area of the base multiplied by the height. So we can fill what we know now. So volume equals, well, area of the base, the area of a circle is always pi r squared, and our height is just our h there. So fill what we know. We know pi is 3.14 multiplied by the radius squared, while our radius here is 2. So 2 centimeters squared multiplied by our height, which is 10.5 centimeters. Well, volume equals, we can keep working down, 3.14 times, well, 2 centimeters, which is the radius squared, is 2 times 2, which gives us 4 centimeters squared multiplied by our height, because we haven't used it yet. Now again, we're going to multiply the area of our base. So 3.14 multiplied by 4 gives us a total of 12.56 centimeters squared multiplied by our height, which is 10.5 centimeters. And we multiply the area of our base, which is 12.56, by our height, which is 10.5. We get a grand total of 131.8 3.88 centimeters, and of course it's cubed. Now, one thing I should probably note, I'm doing a different color here. At this step right here, realistically, you can, go through and find the area of the base first, but you could also right here just multiply straight across. Okay, and I'll even show you if you went 3.14 times 4 times 10.5, you are still going to get the same answer of 131.88. So either way, you could just multiply them right across at this step here, or keep going like this just to show a little more work. Either way, you're going to get the same answer. Let's move on to the last question here. Okay, last example. So here we've got, as you can see, a new cylinder on its side. It's got a height of 2.5 and a diameter, because it's all the way across here, so all the way down, of 7.6. So we'll solve this quite similarly to our other ones. So just quite simply here, our volume we know is the area of the base multiplied by our height. We can fill in that. So we know the area of a base of a circle is going to be pi radius squared multiplied by our height. Well, here we don't know radius, though. We have to make sure we figure that out. So in order to find that, we know that diameter is the distance right across the circle, and radius is actually diameter divided by 2, because it's half the distance across the circle. It's only to about here. So radius equals, well, our diameter is 7.6 divided by 2, so our radius becomes 3.8. So when we fill this in over here, our volume equals 3.14 multiplied by 3.8. Now, times 3.8. So times our height, which we know is 2.5 centimeters. Now we just do the work. So we know that our volume is going to be 3.14. 3.8 times 3.8 is going to give us 14.44 centimeters squared, multiplied by our height still, which is 2.5 centimeters. Now all we need to do is multiply them all together, but I'm going to go just that little one step extra here, and I'm going to multiply just my 3.14 times 14.44, which gives me a volume of my base of 45.3416 centimeters squared, times our height, which is still here, and as a total, we're going to get our volume of 113.354 centimeters, and as always, cubed, and that is our final answer. So really, if you just make sure you're following along with this formula right there, you're going to get it every time. Like I said before, you could probably just finish it on that step right here if you wanted to. I like going the extra step just so I know exactly what this is right here. And then I just had that extra step, but it's up to you, whatever you feel works best for you. But that's my steps in defining the volume of a cylinder. So you can go on from here and work on your assignment from here, and we'll talk in class tomorrow.